Hi everyone, today's topic is Lacey's theory and we also do one numerical. So the first step of Lacey's theory is to calculate the velocity, that we have the formula q square by 140 to whole power 1 by 6, where f is the self factor and we have the formula f equal to 1.76 root under dmm. Now we will find out the hydraulic mean depth r, whereas r equal to 5 by 2 v square upon f. The v is already calculated and f is the self factor. Now the third step is to calculate the area of the channel. We have the formula from the continuity equation q is equal to AV. So from there we will calculate the area of the channel section. The fourth step, we will calculate the weighted perimeter. Now finally the bed slope is determined by the given equation. Here we already have the self factor and given discharge. So finally we will calculate the bed slope as. Now we will solve a numerical. Here we have to design a canal using the Lacey's theory and the discharge is here 20 cubics, where the self factor f will be 1.5 and the side slope is 0.5 is to 1. So z will be 0.5. We already discussed the steps of the Lacey's theory. Now from the Lacey's equation, the first step is to calculate the velocity. We have v equal to qf square by 140 whole power 1 by 6. So calculating this, a q is 20 cubics and f is already given 1.5 by 140. Here we get the velocity is equal to 0.82 meter per second. Now we will calculate the hydraulic mean depth. So from the formula v equal to root under 2 by 5 fr, we will calculate hydraulic mean depth. V is equal to 0.82 meter per second, which we have already calculated above. Value of hydraulic mean depth is 1.12 meter. Now the third step, we will calculate the area of the channel, which is q by v. So discharge is 50 cubics, whereas velocity is 0.82 and we will get the area 60.97 square meter. Now in the first step we are gonna calculate the perimeter. The weighted perimeter will be calculated from the discharge perimeter equation, whereas discharge is 50 cubics. So the answer will be 4.75 root under 50, which will be equal to 33.58 meter. Since we already have calculated the area and the perimeter, now we will consider this as a trapezoidal section so that we can calculate the base of the channel and the total depth of the channel. So considering this the trapezoidal sections, we have the equation p equal to base plus 2 times of depth root under z square plus 1. That will be the equation first, and whereas a is equal to by plus zy square, we will consider this as equation 2. Now we will solve both of the equations. Since from the equation first, here we will solve for the base, whereas base will be equal to from equation first p minus 2y root under z square plus 1. Now we have already calculated p equal to 33.58 and z is given 0.5. We are going to make an equation where b is now equal to 33.58 minus y root under 5. That will be equation third. From equation second, we have area equal to 60.97. We have calculated the area above. V equal to by plus 0.5 y square. We will solve these equations by putting the value of b from equation third, and we will solve this in calculator by solving this equation in calculator. Here we have calculated the value of the depth, which is 2.02 meter. So calculating the depth, we will get the base from the equation third. From equation third, we have to calculate the depth of the base of the section. Here b equal to 33.58 minus 2.02 root under 5, that will be calculated as 29.06 meter will be our answer. So therefore here we get the value at the width of the section is equal to 29.06 meter and the depth of the section y is equal to 2.02 meter. Now in the very last fifth equation we will calculate the base slope, which is equal to f power 5 by 3 by 3340 times q power 1 by 6. We have already given the value of the silt factor, which is 1.5, and the discharge is 50 cumex. That will be the insert 0.0003, which is equal to 1 by 3000 will be the slope of our given questions. So this is all about the Lacey's theorem equations and its numerical. For more numerical we will solve in another video. Thank you.